is as large as possible, as small, is as large as possible, as small as possible. Okay, so that's the sum. And again, let's write y as 20 minus x. Differentiate with respect to x. So 1 equals negative 1 over 20 minus x on square root. This time, for some reason, I wrote the sum on the right side of the equal sign. I don't know why, just I happen to do it that way. But it doesn't matter. The process stays exactly the same. And so this is the derivative. Is that the correct derivative?
Yeah.
I think I'm missing something.
E 1 plus. 1 E 1 plus.
Oh yeah, well that's true. I'm missing something else too though.
1 over 2 root.
Yeah, there should be a 2 down here. All right, just as 1/2. Okay, and then we set that equal to 0. Then I multiply both sides by my common denominator. And we get 2 times the square root of 20 minus x minus 1 equals 0. So the square root of 20 minus x equals 1/2. So I'm going to add the 1 over and divide by 2. I'll let people catch up. Some people are almost done. I'm solving for x, so what do we do to both sides? Square it. So 20 minus x equals 1/4. So 19 3/4 is equal to x, which means what will y equal? Yeah. Now we still need to figure out if this is a max or a min. What's that?
Where'd you get the y equals 1/4?
Yeah, I know this add up to 20. That was the thing from the beginning. Okay, well, how do we find out if it's a max or min? We take the what? Second derivative. So we get to take the second derivative of that. That doesn't look like very much fun, does it? So maybe we can choose something else. Or maybe we can do it a different way. Any ideas? No ideas. Is there a calculator? Okay, no ideas. We'll just do the second derivative. Oh, we're taking the second derivative, yeah. So we're taking the derivative of this. So the derivative, negative 1 over 2 times the square root of 20 minus x. That is equal to, see, I just don't really want to do this. Do you guys want to do this? I'm not going to just not do the problem. What I'm saying is, this just looks really annoying. So let's see if we can do this a different way. I know that at 19 3/4, we have a critical point. So to the left of that, like at the point 19, somewhere there. When you plug that into this is my derivative, first derivative. When I plug that into here, we get what number? Negative 1/2, right? So over here, this is negative. Let's look at another number to the left of 20. If I plug in 20, we get 0. That's bad. So, I don't know, 19 and 7/8. This becomes the square root. Actually, let's use like 15 over 16. Yeah, that's better. Because when I do 20 minus 19 and 15 over 16, we get 1/16. What's the square root of 1/16? 1/4. 2 times a fourth is 1/2. We still get a negative number, don't we? Oh, that's not what I wanted.
Add 1.
What?
From the top.
Oh, yeah, we were supposed to add 1. Thank you very much. Yeah. We're looking at, this is my derivative. This is my derivative, right? That's confusing with the different colors. Adding 1. So we got a over here. We got a negative number, but we got a, or did we get a negative? Maybe we didn't.
Negative 1 plus 1 would be 1 half, so it would be
So this
positive.
is 1 plus negative 1/2 equals a positive. So this is it's positive numbers over here. And 19 and 15, 16, that gave us a what again? 1/4, 2 times a fourth is 1/2. So that's a negative 2, so that was 1 plus negative 2, so that's a negative. So here's the moral of the story. My derivative went from positive to negative. So what kind of point is that? It's a maximum. You guys follow along what I was saying? I mean, sometimes it's easier to draw a little line and draw your critical point and plug in a number to the left, plug in a number to the right, and see if it goes from positive to negative or negative to positive. And based on that observation, you can find out if it's a minimum or maximum. You know, again, we could always take we can take the derivative. That's negative 1/2 times 20 minus, can't write, x to the negative 1/2. With the power rule, you get 1/4, 20 minus x to the negative 3 halves times negative 1. And plug in your value, and you're going to get a negative, because it's times negative 1. And so you know it's a maximum. But, anyways, max. How do we figure out if how do we find our minimum value? As small as possible. What do we check? I already told you earlier. Check the endpoints. So it would make sense to make it as small as possible. We let use the big 0, right? So 20 plus the square root of, well, actually, you just 0 plus the square root of 20, right? 20 is your minimum. That's how you do it. That's right. I haven't even looked at my answers. You're not actually here, but you want to look at the solutions guide? All right, that's it for that one. The red one.